All right, let's talk DP operational planning. If you're stepping onto a dynamically positioned vessel as a new officer, think of this as your essential briefing. We're going to cover the critical documents that make sure you can hold your station safely, effectively, no matter what the sea throws at you. So let's dive right in.
You know, on a DP vessel, the most important move you can make is often no move at all. It's all about precision, about holding your position within just a few meters, sometimes for days or even weeks. And your ability to pull that off safely? Well, it all comes down to planning. What we're about to go through isn't just a pile of paperwork. It's the operational playbook that protects the vessel, the mission, and every single person on board.
So what's actually in this playbook? It really boils down to 3 core tools that you, as a DPO, have to know like the back of your hand. They are the Critical Activity Mode, or CAMO, the Task Appropriate Mode, or TAM, and the Activity-Specific Operating Guidelines, which everyone just calls the ASOG. Let's break them down.
First up, CAMO. The easiest way to think about CAMO is that it's your vessel's gold standard. It's the most robust, most fault-tolerant setup you can possibly have for your power plant, your thrusters, all of it. This is the mode you must be in for any critical operation. The whole point is to make sure that a single point of failure, like one generator tripping or thruster going down, doesn't spiral into a major incident.
Now, you're not always going to need that Fort Knox level of security, and that's where TAM comes into play. Task-appropriate mode is a risk-based setup you can use when the consequences of losing your position are, well, acceptably low. But listen, switching to TAM isn't something you do on a whim. It requires a formal risk assessment and total agreement from the team that the danger has significantly decreased.
So here's the absolute key difference you need to get. CAMO is all about maximum protection for high-stakes work. Your goal is to guarantee that no single failure can cause a disaster. TAM, on the other hand, is for when the stakes are lower. You're accepting that a single failure could potentially cause you to lose position, but only because you've done the homework, the risk assessment, and decided the outcome wouldn't be catastrophic. It's really about matching your defense level to the threat level.
And that brings us to our third tool, the one that ties it all together, the ASOG. Okay, so if CAMO and TAM define how your vessel is set up, the ASOG defines your boundaries. It's your live, dynamic game plan for the specific job, right here, right now. It tells you exactly what your vessel can handle in terms of wind, waves, and current, and what to do if a piece of equipment acts up. And these limits aren't just pulled out of thin air. They come from hardcore capability plots and simulations.
Okay, so how does the AOS actually work on watch? Simple. It uses a really powerful color-coded system to help you manage risk in real time. Think of it as your at-a-glance dashboard for the vessel's status, guiding you from everything's fine all the way to a full-blown emergency. On every single watch, this is the question you have to be asking yourself constantly. Green, yellow, or red? What is our status? Knowing the answer and exactly what to do for each color is the absolute core of your responsibility as a DPO.
Let's walk through what these mean. Green, that's your happy place. Normal ops, continue as planned. Advisory means something's up. It's not an immediate danger, but it needs your attention and a risk assessment now. Yellow. Yellow is a big deal. You've just lost a layer of redundancy. The operation stops, period. You start preparing your escape routes. And red, that's it. It's an emergency. You are losing position, and your only move is to get out of there immediately.
Let's see how fast things can change. You start your watch in green. Everything is set up per the CAMO. Then an alarm goes off. A backup air compressor has failed. No immediate danger, but you're now in advisory. You need to figure out what this means. Before you can even finish, another alarm. A bow thruster just tripped offline. That's it. Your redundancy is gone. You are immediately in yellow status. Stop the operation. But it gets worse. The fire alarm rings. It's confirmed in a DP critical space. That is red. No thinking, no hesitation. You initiate the emergency disconnect. That's how fast your world can change.
So who actually creates these incredibly important documents? You have to understand this. This is not a solo job. It's not something one person drafts up in an office. Real, effective operational planning is a deep, collaborative effort that involves key leaders from all across the vessel.
The core team absolutely has to include the master or OIM, who has the ultimate authority, the chief engineer who knows the power plant inside and out, its strengths, its weaknesses, and of course, you, the DPOs, the ones who have to execute the plan. And for specific jobs, you'll bring in the project leads, like the driller or the dive superintendent, because their operational needs have to be part of the plan too.
And this planning isn't based on gut feelings or just what you did last time. No, it's rooted in hard engineering analysis. The CAMO is a direct result of the vessel's FMEA, the failure modes and effects analysis. The FMEA is this huge, exhaustive study of everything that could possibly go wrong and what the consequences would be. Your CAMO is the operational answer to that study, designed specifically to protect you from the biggest risks they found.
Okay, so we've got our team, and we've got the foundation of our plan rooted in solid analysis. Now let's talk about the final checks and procedures that turn that piece of paper into a safe operation.
Before you even think about entering that 500-meter zone, there's a checklist, and it is non-negotiable. We're talking about load testing all your uninterruptible power supplies, confirming the power plant is set up exactly right, usually with bus ties open, verifying you have at least three independent position reference systems online and working. You're going to test your thrusters to 100% and make sure every DPO and engineer has recently done a blackout recovery drill. These are safety gates. You don't pass until they are all checked off.
Once the plan is solid and all the checks are done, it needs a formal sign-off. And this isn't just passing a clipboard around. This is a dedicated briefing where the master, the chief engineer, and the DPOs all review it together and physically sign the document. That signature, that's a shared commitment. It's everyone saying, I understand the plan, I agree to the limits, and I accept my responsibility for the safety of this operation. And finally, a simple but absolutely critical rule. You cannot file this plan away in a drawer. The CAMO and the ASOG must be posted, right out in the open, clearly visible at all times. One copy at the DP control console and another in the engine control room. Believe me, when an alarm is screaming, you won't have time to go looking for a binder. The guidance has to be right there in front of you.
So, the plan is made. The checks are done. Are you ready for your watch? This whole process, all of it, from that deep dive FMEA analysis to that final signature, is designed so that you can answer that question with a confident yes. It doesn't get rid of risk, nobody can do that, but it gives you the framework to manage it. It gives you the tools, the procedures, and the confidence you need to command your vessel with precision and with safety. And that, right there, is the heart of being a professional DPO.